Welcome to the Box Lunch crowd. My name is Bob Ward from Microsoft. Thank you for being here today. I really do appreciate you customizing your schedule with your lunch to come here. Perhaps maybe Tuesday morning's roadmap session should have been in this room. Agreed? Yeah, I wish so. Well, thanks for coming today. Today's talk is about inside SQL Server containers. Let me say a couple things about this talk before we get going. Number one, I do have a little bit of reputation over the last several years for SQL Server community to do inside sessions. And so anytime I do an inside session, I'm going to tag it to be the highest level or the most complicated level in the conference. But everybody who's seen my talks is used to a debugger. That's not going to happen today. Sorry about that. So maybe you won't like the fact that I put it at level 400. But I do think that you will think it's a fairly advanced level. And when you do pick a 400 level at a conference, you're allowed to do a couple things. You're allowed to go extremely fast, so we're going to do that, right? Do a lot of command line stuff, and probably just take questions at the end. We have a huge room in here, pretty hard to take questions right in the middle of it. So I'm going to leave some questions for the very end, but here's my commitment to you, and if you know me, I'm very serious about this. My email's up here on the screen, bobward@microsoft.com. If for any reason anything I say here just is confusing to you or you need follow-up questions, especially when it comes to SQL Server and containers, I promise you I will personally address your question over email. And in fact, what I do over the next 2 weeks is I really pay close attention to emails coming outside, folks from outside the company, and make sure I address those. A couple things, and if you want to take a photo of this screen, it's fine, but when you get the deck on Microsoft Ignite, you can see it. But take a look at these URLs, aka.ms, bobward.ms, and then the other one is a GitHub site for my GitHub repo. So today, this afternoon, I will be uploading this deck to that first site, aka.ms, bobward.ms, and the demos that I'm doing today will be uploaded to this GitHub repo site. So a lot of command scripts, a lot of things I'm going to be typing in, and you're going to be going like, how do I follow this stuff, and can I do it myself? And the answer is yes. When you leave this conference, you'll have access to this deck and every single script that I've done on here, and we'd love your feedback about it. So let's dive into this, and like, how are we going to do this in 75 minutes? Like, how are you going to cover this thing? Well, number one, we're going to talk a little bit about Docker first, independent of SQL Server, to kind of set the stage about SQL Server. The intention of the talk today is for you to walk away and understand how we did this. How does SQL Server run in a container environment, and what's going to be possible for you, okay? It is not too much of a dive deep into Docker internals, although I'm going to talk about it some. But it's more about how SQL Server leverages a container environment, and under the covers, how do we pull this off? And so we're going to talk a little bit about that. And then at the very end, I'm hopeful that we'll talk a little bit about Kubernetes. The talk was really more designed to be about Docker and Docker containers. But if you know anything about the Kubernetes environment, which is an orchestration platform to run containers, we're leveraging that. I will briefly talk about that at the end. And then I plan to do lots of demos. So let's talk a little bit about Docker containers. And it's interesting, as I was actually making changes to this slide over the last couple of days, it was somewhat based on questions I got at the SQL Server booth area. And that is, what is this image thing that you're doing? What is a container image? Well, first of all, really what it comes down to is just a layered snapshot of files structured in a file system. And it's put into a package format so that you can portably take it around. Anywhere Docker runs, we can take a container and go run it. You name the platform, we can do it, right? It really comes down to and why I call it a structured layered snapshot of files is usually start with some sort of base image of files, and then you add on top of that. And then you build these images, and this is what we do, using a file called a Docker file, which is well documented in its format, and you do it using a program called Docker build, or a program called Docker with a build parameter, or there's actually a set of APIs, so if you want to programmatically generate these things, you can do that. And then most of these are always built with a base image. And today's focus is about Linux, SQL Server on Linux Docker containers. And so most of these Docker containers for Linux are based on a base image of a Linux operating system. And today for SQL Server, we actually have SQL Server base image of Ubuntu. And then we announced here at the conference Red Hat images as well. So what about the container? Well, I've seen this term before, a runtime instance of an image. What the heck is that? Well, if you really look at these things and you go run a container, all it really comes down to is run a program that's in those set of files. That's really what it is. And you're going to see with the magic of SQL Server is that that's what we do. We just actually run SQL Server, but it could be a script. It could be any application or program that you've put into this actual image set of files. Now, the intention is that they're isolated. That's the whole purpose of doing one of these things, that all these containers, if they run in the same system, have an isolation property to them, but they can communicate to the outside. For SQL Server, that's necessary, right? You're going to run a SQL Server container, you got to be able to connect in and run queries to it, and so they have that property. Here's an interesting thing that many people don't know. They have access to all the CPU and memory resources on the host it's running on, whether it's a virtual machine or a bare metal machine. So a given container for SQL Server would have access to all the physical memory on that machine or CPUs. And we'll talk at the end a little bit about how you might control that if that's necessary, because you might be running multiple containers. Now, each container has a writable layer. And what I mean by that is that you take this image and you run it, and that's all read-only. And then you might want to make changes inside it. And so you can do that and interact with the container and make changes, and that's called a writable layer. Well, why is that important? Because when you start one of these containers and stop them, that writable layer or changes to files on that set of file infrastructure stays the same. It's actually, at that point, available to you, and you don't lose that information. But if you decide to remove the container, you will delete that writable layer will be unavailable to you anymore. And what if that's a SQL Server database? You have to find a way around that, and we've got a solution to make sure that your database files or any files are persistent in something called a volume. And that's the comment here, is that a volume can provide persistence, and of course that's really, really important to a stateful system like SQL Server. Now, I've seen a lot of people talk about containers in terms of a lightweight VM. What is it? Emulation, all sorts of things. It really comes down to this for me, and that is VMs emulate hardware and load an entire operating system in their environment. So they're isolated, and you can communicate outside with them, but a hypervisor VM environment is actually doing that type of technology, whereas the containers can provide isolation, but they cooperate with the base operating system. And you're going to see the examples of this is where you're going to be able to look at a Linux operating system and see the actual processes running in a container just like you would see other processes, but they have this unique isolation property. So this is a little bit about the container lifecycle if you're going to do something like do your own containers, and this is what we do at Microsoft. So we actually use a Docker build command. A Docker build command is a client program that you can use. There's all sorts of options for the Docker program on any operating system you pick. And a build is going to take that Docker file concept and take an image and build it. We'll talk a little bit about the properties of that in a second. And then you can push your Docker image to a registry like Docker Hub. We announced at this conference for SQL Server and other Microsoft properties have this. We have a new Microsoft Container Registry. A registry is where you push and store your images for others to consume. It actually could be a private registry on your network or on a local machine. Or it could be a public registry. Azure has a service for that as well. It could be Docker, it could be Red Hat, it could be something now called the Microsoft Container Registry, which is what we now use. So once these things are published out in this registry, you then can go consume them by pulling them down from these registries. Could be private on your network. And then once the image is pulled down, that's pulled down into something called a repository. A repository is just a file structure on your system. And then you're allowed now to interact by running those containers. And there's a program called the Docker daemon that runs on a Linux machine that controls all of this stuff. It's the one that interacts with the Docker client, which is the Docker program, to orchestrate pushing, pulling, building, running, all of those type of properties. And then notice on the right-hand side, my little icons here. This is a really cool thing about Docker that I absolutely love, is that the consistency exists for using the Docker client, all those commands on these operating systems, Linux, Windows, Mac, and even a cloud service like Azure. So under the covers, I'm an API guy. I love to figure out, like, what are these programs doing? Because what is the magic? Did Docker create something that no one else in the world can do? And that's actually not true. So for a Linux operating system, the Linux kernel provides these concepts, namespaces for process and network and other resource isolation. That's the isolation concept that that Linux provides, so that, in other words, these containers can run in an isolated way but still communicate on the outside. There's something called a union file system concept. That's a layered file system so that if you run 10 containers with these file structures, the structure part of it that's read-only that's the same is only actually saved one time on the system. And then the writable layers are actually differences among those. And Linux provides something called a union file system to make that functionality possible. And then control groups provide accountability, governance, and notifications. So I told you that these containers have access to CPU and memory and resources. C groups or control groups provide the functionality of controlling those resources. For example, you could affinitize a container and say only run on this particular CPU, or only give it this amount of memory on a system. So those are the Linux kernel concepts, and Docker uses a set of libraries called libcontainer that they publish that they use to go against these Linux resources. So you yourself could build your own container environment because there are Linux API calls across namespace, union file system, control groups that you yourself can take advantage of. And Docker uses a concept called libcontainer to interface with all of those things. So I'm not going to go to every single command because you can see me actually use these, but these are the type of options of these commands that you're going to interact with a lot. And I'm going to leave this for you to go back later on this slide to see what are the ones I commonly use. The reason I also point out in the upper right-hand corner is that anytime you have programs like this, developers always want to know, can I program it? I could script it, but can I write the actual code? And the answer is yes. There's a Docker SDK and APIs for you to do anything you want with all those type of operations. And then finally, I won't go into an example today, but you can use something called Docker Compose, a separate program you can download, a package, to actually go build multiple containers that have dependencies on each other. My colleague Vin Yu was up here at lunch yesterday, not in this room, but a different room, showing Docker Compose. He's got great examples of how to do Docker Compose. And in fact, in the resources page at the end of this talk, I have a pointer and a GitHub repo where you can go yourself and try some Docker Compose labs that Vin has built. So let's do a little demonstration of some basics of Docker demos, of the actual Docker system itself. Let me flip over here to 8. And with the magic of voila. So this is actually on my Windows laptop. I'm using a program called MobaXterm. It's my preferred secured shell. I'm shelled into a Linux Red Hat VM on Azure. And these are some of the scripts I'm going to be using. So if I look at this first, one thing I can do here just to see what's on my system is something like sudo docker images. Let me put in my password. And on here, I'm going to see images that I've pulled down. Now, you're going to find out and see that you could do this Docker pull command to pull these things down from a registry, or when you actually run a Docker container for the first time, if it doesn't exist locally in your repository, it'll pull it down automatically. So you can kind of see here some of the ones I've already got on my system. Maybe I've been playing around a little bit. Can you see maybe SQL Server as one of the things that I've actually got done so far? So I've already been running demos on here to pull various Docker images down. And the really cool thing is, once you pull them down, when you start using these containers, once you've pulled it, it doesn't have to pull down the second time. You have the ability also to do a pull to update the image. So if there's an update to an image of the same one you pulled before, another Docker pull just actually updates it. So one thing I thought would be interesting for you to see is like, what do these images actually look like? So there's actually an interesting command called sudo docker inspect, and I can pick one of these. Like, let's pick SQL Server 17 image and run an inspect, and I get a JSON file that comes up here, and it has all sorts of information about that image. So I scroll way up here, and you can tell, and you get information about like where was this pulled. You can see here, there's the Microsoft Container Registry URL where we pull images from. And then you got all sorts of other properties about this, including, and this is what I like right here. Let me scroll down here. First of all, so this is the command to run the image. We'll show you in a second in SQL what that actually means. And then down here, if I can find it, this is what I like right here. This right here are directory locations of where the images are. So this is like the repository on your local machine. So you can take any Docker image and find out, well, where does this stuff actually exist on my actual hard drive so I can see where it looks like. And this is an example of where the read layers that I talked about that exist for the image. So that's kind of a way to inspect any image. And you can do Docker inspect on many different types of objects in the Docker system, and you get this JSON description internally of what that actually looks like. So what if I actually run one of these guys? Let's run this one, Hello World. So the Docker guys were clever. They actually published an image called Hello World, and I'm going to run it. Whoops. And you're going to see what it does is it didn't find it locally, so it actually downloads it and it starts running it. You'll notice on the bottom of the screen there, though, that it says it exits. It's like, well, wait a minute. Aren't these container things that you run and they just stay up and run and then I use them? Remember what I said earlier, a container is just a set of files. An image is a set of files, and a container is a program you run. Well, if you run a program in your container that just runs and exits, the container exits. So what you typically got to keep in mind that if you want to run a container that stays up and runs like an app you're building, then your app needs to stay up and run. It doesn't want to exit. But Hello World is just a quick program that just runs and exits. So that's really not all that interesting, except that you might want to start seeing what's running on the system. So I could use a command like this, sudo docker ps, sudo docker psa, and that tells me what ran on the system, like what's running now and what ran. So it's kind of like a little bit of a history of what Docker containers were there. I could try to start that container again, but it's just going to turn around and exit again. Well, that's not all that really interesting. So what about another one? I've got here something called Docker bash. And if you look at this command here, what it's going to do is run a Docker container based on an image just called Ubuntu, which is the base Ubuntu image for Linux. And it's going to run a program called bash. So all it's going to do is just run a shell, and it's going to do it in a way that's interesting. Notice this -d command. -d says run it in the background. So I'm going to say docker bash.sh, and it's going to kick off and run in the background. Well, okay, so what do I do now with this thing? Well, you can actually do something very clever. You can, and I call this script bash and docker. That's kind of interesting name. I have no Dallas Cowboy names today. I'm sorry for you. Since we lost Sunday, I'm getting completely humiliated by my Seahawk friends. So there's no sports teams names in these scripts. So I do bash in docker.sh, and check this out. Notice that I've got a command prompt that looks like a bash shell. Here's what's really cool about Docker. Once these containers run, the Docker client allows you to interact with the container directly. You can copy in files, or you can actually start up a shell and then start running in the container. Well, why is that interesting? Well, let me back out and show you again. Now, if I do this command here, ps-axf, this shows me processes on the system. And I want to show you this right here. Remember I mentioned this Docker daemon program? See if I can get this here. Here is the Docker daemon program, and notice this is kind of a tree view of Linux processes. And notice that bash is at the bottom. So this shows you that the Docker daemon, and it does a process called cloning a process, not forking. It cloned this bash process now. And if you'll notice here in this case, the bash process ID is like, I don't know, it's 17528. But if I go back and interact with the shell, and I do this command, whoops, I have very few processes. And this is kind of the power of Docker, right? I'm now running in this contained environment, and I only see what I ran. There's no other process running in here except the one that I started. And this is a little bit of a misnomer. People think that I've loaded the Ubuntu operating system in this container. That's not true. I've actually just a set of files that represent what Ubuntu looks like, but I'm not running everything that Ubuntu has that's addition to just the base kernel. I only run the programs that I said for the container to run. And notice the process ID for bash is just a 1 because the daemon has actually cloned this off. Now, I told you there was a concept called namespaces, and there's actually a command for you to see these. So if you look at namespaces.sh, there's a command called lsns. And again, I have all these scripts for you so you can go back and run this yourself. And here's the interesting part. Here are the namespaces specifically for my container. So anytime you run a bunch of containers, you can run this namespaces command and you can see all of these things. And to be clear about this, namespaces are a concept independent of Docker. They're a concept that the Linux kernel provides for any program to use for isolation purposes. Docker takes advantage of it as part of its architecture to provide what I talked about in this isolation concept. And the concept is isolation of file systems, processes, networks, inter-process communication, all that type of functionality. Let's see if there's something else I wanted to show you about this. Oh, yeah, I did want to show you this. So on a given Linux system, I can run a command like this to see what kind of Linux distribution am I running. And I will. And notice it says Red Hat Enterprise Linux. If I go back and interact with that Docker shell again, and I do the same thing, notice it says Ubuntu. So that's how you can see now the fact that I'm on a Red Hat host running Ubuntu containers. But you could run a Red Hat container or a different type of Linux distribution container as well. So that's just kind of a basics of kind of how you see under the covers what Docker is doing. Okay, I'm going to set myself up for the next set of demos because we're going to dive into what SQL Server actually looks like. Oops. Okay, back to my slides. So let's unpack a little bit about the SQL story. Now that you kind of get a feel for what you might do with Docker, okay? So number one, let's talk just about images to make sure we're clear about this story. Because this was I actually made some changes based on questions at the booth this week at this conference. Public registries where SQL Server has its images is on the Microsoft Container Registry. What we've done now is syndicated or basically linked from Docker Hub and Red Hat Container Catalog onto that registry. So Ubuntu and images will be found on Docker Hub, but they're really stored on the container registry. You don't browse the container registry, you'll browse it from these other sources. Second of all, what do we have out there? We have a SQL Server 2017 Ubuntu set of images. We have SQL 17 RTM, our release to manufacture, plus each CU and GDR has a separate image. That's pretty cool. So it's the same concept we're doing in Linux and distributing our product. If you want SQL Server 2017 CU10, you just go do a Docker pull of CU10 and you get CU10 built in. Of course, it's cumulative, right? So you get every update in between. It's all packaged in the system. And in the actual image, we include the SQL Server product and the SQL Server tools itself. And you're going to see how a clever way we've done this where we've actually pre-installed the software for you, which is one of the great benefits of it. Now, we just announced SQL Server 2019 as a preview, and we have that available now for Ubuntu and RHEL. And in there's the same thing, the SQL Server and the SQL Server tools. So would I even go after and do this? I had a question at the booth, that's why I added a slide. Like, what is the advantage of this? Besides all this isolation things you're talking about. Well, guess what? SQL Server is pre-installed for you. The engine and the tools are all pre-installed in this package if you just pull it down and start running it. In fact, I would challenge you that if you leave this conference, the quickest way for you to start learning SQL 17 and 19 is containers. When I talk to Vin Yu, my colleague, who's an expert in containers, I think that's all he does now. He has his MacBook, and he just runs containers on everything he does for SQL Server. He did a demonstration Wednesday in our talk where he did a SQL Server replication, and he had a publisher and subscriber all using containers on his MacBook. I mean, does that sound crazy to you? Run SQL replication on a MacBook? That's what we're doing now, right? And that's what he set up, and that's the power of what we're bringing with containers. The tool's pre-installed, it's a SQL Server engine, and here's the other part. It is completely compatible. It is SQL Server Linux running in these containers. So you can take a database that you've backed up on Windows and restore it into the container for SQL Server 17, and it just works. You can point Management Studio to it. You can point new Azure Data Studio to it. It's got the compatibility story because it is the SQL Server engine. So how do we build this thing? What does it actually look like? Well, I told you that to build an image, to start with, use a Docker file. And this is kind of the format of what our Docker file looks like. We use Ubuntu or RHEL as the base image. We put a label around it so you can see the tags and version information about our image. And then we do something called an expose. This is the format of this file, and the Docker file has a protocol to it on these tags you use. It's just a text file. The expose says, take port 1433 and expose that available to anyone to connect to. Okay? Then the copy command is the interesting part. So here's what we do. We pre-install SQL Server on a machine. So it's already laid out. And then we just copy the binary libraries into the image. That's that stackable thing I talked about. You've got the base Ubuntu image. We're copying in our binaries and libraries into that image now. That's the next layer of it. And then this install script that we run, we copy it in this install script as well. What it does is install some other dependent packages for us, the tools package, right? And does a couple other things to get this all ready. And then notice the CMD program. Like, what the heck is that? Well, let's kind of unplug it a little bit. Number one, when you run containers in SQL Server, you can just use port 1433 if you'd like. But we don't support SQL Server named instances on Linux. And I get this question still all the time, like, how do you do that? Well, you do it with containers. And what you do is, you're going to see I'm going to run a Docker command to map another port outside the container system, a different port number to 1433. And that's how you're going to connect to the system. The binaries that you pull in are just what you would normally see on a Linux system, optms, SQL bin, and lib. Effectively, that's where we're copying in. And I'll explain how we're going to actually create all the system databases in a second. And then we install these packages and tools, and then here's the part that's interesting. It's like, wait a minute, How do you start up SQL Server? Well, we just run the SQL Server program. And SQL Server, as a binary program, has a couple of interesting properties. One, if you run it from the command line, it's smart enough to go unpackage everything it needs, like system databases, put them in the right directory, and start up. The second thing it does, it just stays up. So instead of running it like a service, a lot of you folks are probably Windows users who are used to running SQL Server as a service, and it just runs all the time for you, right? Well, it turns out even on Windows, you can run SQL Server from the command line, and it's built to be a program that just waits to be killed, basically. It just runs all the time, like a daemon-type program. And that's kind of how we pull off this magic. By the way, if you want to know, SQL Server Docker files on GitHub, the actual Docker files we use are all out there available for you to see. And then if you want to get more into Docker files yourself, because we're going to talk about a little bit how you could customize what we've done to your own purposes for other types of needs. So, okay, we copied in these binaries, we run this command SQL Server. I'm still not getting how you actually run this system. How does it work? So the Docker image contains the binaries, libraries, and something called a package files. For SQL Server on Linux, you'll find this in the directory structure. There's a set of files called .sfp. Inside there are interesting properties of the SQL Server binaries for Windows and the system databases. And when you run this container, in the beginning, this opt MS-SQL, which is where the system databases are, which is where the error log things are, that doesn't exist. So you're like, okay, well, if that doesn't exist, how does this work? Well, here's the magic. When SQL Server starts from the command line, if you actually set up these environment variables, accept the EULA agreement, set up an SA password, and tell us what edition of SQL Server, which is optional, so developer's the default. So if you just do the first two, which you'll see in the Docker run command in a second, SQL Server from the command line will accept, on Linux, those command line parameters, fork a new SQL Server process, which is the actual engine itself, take the variables and turn those into startup parameters for SQL Server engine itself, and then the opt MS-SQL structure is now created and populated with all its system databases, extracted from those files, and then the engine just now runs. It's really clever. It's a way for us to create an image for you without, we don't actually run the install of SQL Server when you start up a container, which is why it's pre-installed. And it's why the engine has the intelligence to finish off what we've copied into the image itself to make an installation. Okay, so you have one of these things, you've pulled it down, or maybe you run it without pulling down, and what are the different parameters I would normally use to do this? And this is a very common pattern that you're going to see us show you how to run a container for SQL Server. Number one, I mentioned those environment variables. So you're going to set those two environment variables to whatever you want. The EULA, the password. In this particular case, I didn't set a PID or an edition of SQL Server, but you could. You could say I'm running Enterprise Edition because I have a license for that. You can put that in there. The second parameter is the -p, and these are parameters for the Docker run command, by the way. The second parameter is a port mapping. I mentioned before that we don't have named instances on Linux, so how do you achieve it? What you do is you map different port numbers to 1433, which is in the SQL engine, and now multiple SQL servers can run at the same time and listen on different ports. Another question I get, and I'll stop for a second, is I didn't think two SQL servers could start at the same time and access the same set of databases, the same system databases. Like, how are you doing this? Remember what a container image is. It's a set of files, right? It's a set of files out there that are isolated from each other. So in this particular case, the system databases for SQL Server Instance 1 are in a different location than the system databases for SQL Server 2, because it's different. That's the like writable type part of this story, right? And the -v parameter is probably one of the most important. And that is, if you start remember what I said in the very first slide, that a container, the writable layer, that if you start and stop this container, that writable layer is untouched, right? But if you remove the container, you lose it. So let's say you copy in and restore a database to a SQL Server container, and you don't use this -v parameter. If you remove the container, you would lose your database at that point. But if you use this -v parameter, there's a couple of options here. One, I just called it a name called SQL volume. And Docker will actually turn that SQL volume into a directory on its host Linux machine, and it maps it to var opt MS-SQL inside the container. So anything in that var opt MS SQL directory is now persistently stored outside the container in the host environment. So even if the container is removed, the SQL volume still contains that directory structure and any changes you make to it intact. The name is just a convenient tag. I always use names, always use a name. Otherwise, you're going to have to look at this list and find these GUIDs to go to how to control, start and stop, and manipulate your container. So pick some name that makes sense to you to describe the container. The -d is the interesting part. So -d for Docker says run it in the background. And you saw the example when I did that with one of the Docker ones I just showed you with bash. What if you didn't do that? What would it look like? Well, I think I have an example to show you. Basically, it just runs SQL Server, and what does SQL Server do if it doesn't run in the background? It dumps the error log across the screen. Now, why would you want to do something like that? I use it for debugging purposes. If you ever customize the SQL Server container, or if you start a SQL Server container and it doesn't start correctly, and I've had this happen before, I just take off the -d, and you start seeing the SQL error log scroll across, and you can see any errors that you've encountered. For example, you put a SQL Server database on one of these volumes. Some corruption occurred, though, on that volume for, like, say, your master database. So you restart your container, and it doesn't start up, and you're like, what's going on? Well, that's because SQL Server started up as a command, and it failed and exited, so the container exited. So if you start it without the -d, you would see the error log scroll across, and you would see the failure. And so you could then go debug the SQL Server problem. So that's what I use debugging for, is I don't use the -d, but I use it when I run most containers because I don't want to see the error log scrolling across my screen. And then finally, the very last parameter is the image you want to use. And again, I think I mentioned a little bit earlier, we have images for SQL 17, for RTM, and every cumulative update that you want to use, plus even a GDR. Like, we've had one security fix for 17, and so we've got a separate image for 17 plus that GDR release. And that's how you would specify which one you want to use. If you just want the latest, I'll show you a syntax of that. You can just put the word latest, and we'll pull down the latest cumulative update for that release of SQL Server. There's a different tag or a different structure for SQL 19, and we've got that documented. I think I have an example to show you as well. So hey, man, let's do it. Let's enough slideware. This is supposed to be a 400 session. Okay. What do I want to do here? What do I want to start? I think I know what I want to start. I want to show you an interesting little experiment I have. So docker run cu10.sh. Okay, let's unpack this. Do you remember that slide I just showed you? Hear me, I'm running this Docker container with these environment variables. I'm mapping that port. I'm using this SQL volume name. I'm calling it SQL 2017 cu10. It's in the background, and here is the location for what cu10 looks like for Ubuntu in this particular case. So let's just start this guy. Run cu10.sh. Oops. I should use auto-completion more. There we go. So here's my sudo password. And it's off and running. That's interesting, okay. Do I know it's really running? So here's one problem about Docker when you run in the background. If it fails, you won't know it by that, okay, if it's in the background. So you got to run this sudo docker ps. There's another way to actually list these as well. And I can see it's up and running. In fact, my docker bash one is still running. I'm going to stop that one. And you can see how I can stop a container. I'll just type in docker bash, and that stops that one. So the SQL Server 2017 cu10 based image is now up and running. I can literally just connect into SQL and start using it. In fact, let me show you how to do that. Well, first, in order to restore a database as part of this, I want to show you how you can interact with the container through the Docker client. So here's Docker copy. Sudo docker cp, which is a Docker client command. I take a database backup, which is wide world importers, sample wide world importers. It's stored on my local host on my Linux machine, and I'm going to copy it into the container. This is an example of modifying and creating that writable layer of in the container. Let's do that. Comes back, no problem. So now I want to restore that database. You have a couple of options. One is to run SQL command as a tool on the Linux host, interacting with that Docker container in a remote way. It could, by the way, these containers could be done access remote. If I didn't make that clear, you could actually take SQL command on a different machine. As long as you have IP access into that Linux host, you could then interact with it. But instead, what I'm going to do is I'm going to run SQL command in the container. and it looks like this. And here's an example. Remember I showed you docker exec it with a bash command? Here I'm running the SQL command in the container. So what it says is I'm going to interact with that container interactively. Here's the name of it. And this is the program I want you to run. And this big long script is just the script from SQL command to restore the database, because the backup is sitting inside the container now. Let's run it. And now it's going to kick off and run. Well, what might I do with this now? I've got this backup. I can start interacting it. And in fact, when this is finished, I'm just going to run a query to interact with that wide world importers database. The reason this takes a little longer than just going immediately and restoring is the wide world importer database is based on SQL 16. So as you may know with SQL Server, if you take a database backup from a previous version and restore it on a newer version, we have to upgrade system tables in that database. And there's several upgrade steps that we perform. And right now, that's what's going on behind the scenes with this container. And when this is finished, I'm just going to run a query against it, and then I'm going to do something really interesting. I'm going to show you maybe a new way that you haven't thought of before about updating SQL Server instead of patching things. But let's run our query first. So you see here, this is SQL command running outside the container. I've got SQL Server tools installed in Linux. Notice right here how I'm connecting to this thing. I just use localhost 1401. That could be an IP address or a host name with DNS of a remote server running a container, right? I could do that if I wanted to. It's all local in this particular case. And I'm just going to query one of the tables in the database. Docker query. And I get the results back. Okay, well, that's really interesting. But what if I actually wanted to, at this point, apply the latest cumulative update to SQL Server? I'm CU10. We actually have a CU11 we just released. What would you do in your normal world in Windows today, or even on Linux? You would update the SQL Server instance itself, right? Apply the update. I've got a new possible way for you. SQL Server is sitting on that SQL volume database, right? That SQL volume on the host system. So instead of actually doing that, instead of actually applying an update, let's see if I've got this command here I want. I've got so many demos to show you. That's the next demo. But I'll tease you and tell you that what I'm going to do in the next demo when I finish with this is I'm actually going to stop that container, and I'm going to start a new container with the latest cumulative update pointing to that volume, and it's going to automatically update SQL Server because CU11 is pre-installed in the image. It is a new way of thinking about patching SQL that you may not have thought of before. And the interesting teaser is, and we'll see if I can pull it off, is you can roll back within the same major release. So that's one SQL Server running. How do I run another one? Well, here's another example of one. Notice in this case, I actually map port 1402 here, so I don't conflict with the other SQL Server running, and I created a different volume called SQL Volume 2. So in this case, the container is running. It's not pointing to the other SQL volume because you can't run two at the same time against the same system databases. So I'm creating a new volume in this case, and I'll kick it off. Oops. And now if I look at Docker PS, I've got two of them running. Now you may ask yourself, how do you know these are different volumes? How do you know that Docker, the second one, doesn't have access to the first one? Well, there's a couple things I can do. I can look at these volumes in closer ways. So let me say, I think I've got it listed here. Let's see. Sudo inspect vols. Yeah. Notice this command here, sudo docker inspect volume and volume 2. And if I run this command, I actually get a look. That's interesting stuff. That shows you the host files for each volume. So on my host machine in var live docker volumes is where the data is stored for var optimus SQL for each container. And the reason I know I can now just dump out what those directories look like, I can tell you that one is isolated from the other. There is a listing of the directories, and you can see the command I use here. I just dumped out these directories, and again, you can see at the beginning, in the top one, the first container contains the wide world database, but the second one does actually not contain that. So that's one thing you can look at to see between containers, how can I tell on my host system where they are? And by the way, that named SQL volume could be a mounted file system from anywhere you can access your Linux machine. It could be remote storage. It could be somewhere else on a mounted disk. So you don't have to put in a name. You actually can put in an actual name of a file system structure that you want to map that volume to. So one of the things I wanted to show you here now is what does the process look like for the Linux daemon? Whoa, here we go. Check this out. So here's the Linux daemon. Notice what it does is that starts up another process to run each SQL server. And this is an examination of the cloning that we talked about. So there's the Docker daemon process itself. It's actually right here. And it uses this clone process to go fork out these processes. So you're asking yourself, like, what? And this is the power of what I'm trying to show you. It's not a virtual machine. This is not a VM. And in fact, if you do something like ps-asf grep SQL server, you can see there are multiple SQL servers running as processes on the Linux host. And that's what I was trying to point out in the beginning of this talk here is that this is why it's not a virtual machine. These are just actual SQL processes. But those SQL processes don't know each other is actually running as separate. And any Docker container you run has that actual property. Let's see what namespaces look like. Remember I told you about this command. You can see here are the different namespaces for each. So here is the namespace 1 for that SQL process. And here is the second namespace. And notice the process IDs are these set of columns right here. Different processes, different namespaces, and that's how Linux manages isolation between the two containers. Now, I also told you that these containers have access to all the resources they need. Let's find out how that actually looks like. So, first of all, if I just want to see how much memory is on this particular machine, I'm going to run these set of commands. And you can see here it's something like a 50 gig machine, virtual machine that I have. So that's how much memory is on the machine. And you can see here that here's the number of CPUs, like 16 CPUs. So if I go into one of these containers, oh, that's because I changed these names. So let's do this, sudo docker ps. So one of these containers is called SQL2. Let's just go into that one. So sudo, here's how you interact with a container like I showed before. You do a docker exec, interactive, the name of the container, bash. Now I can look at the container. So what if I ran some of those same commands, like lscpu? I still see 16 CPUs. So we're going to talk about at the end, you're going to ask yourself, well, I've got 2 SQL servers running. How do I control? Do they all just get all access to all processes? I mean, how do I control those like I would do named instances in SQL Server? We'll talk about how you're going to actually do that. Same thing here. You can also look at proc meminfo and see that each container, in this particular case, this one, has access to all the memory on the system. One of the little tip that you might note about, you can look at this, it says root and then has this little GUID right here. That's actually the image of the container ID. So you can map up like what container ID was actually looking at. And when you run sudo docker ps, here is that container ID sitting over here for each of these containers. Okay. One of the things I wanted to show you, we talked about the fact that SQL Server has this interesting parameter concept. So if you look at this particular script right here, SQL start params, you'll notice a couple things I'm doing. I'm actually running SQL Server on my host machine, so just to show you this example. So I'm going to stop that service, and then notice how this syntax right here, I'm going to start SQL Server from the command line with this -- help parameter, which you didn't know about. There you learned something new today. You can know a new parameter for SQL Server you didn't hear about. So if I run this, let's see what happens. Here we go. So I mentioned before how SQL Server is clever, it runs containers. As long as you put in these environment variables for EULA and SA password, we then will take this main SQL Server Linux process, fork off a new SQL, and we're going to pass it these parameters right here. So you yourself could actually do this on your Linux machine. You could stop SQL Server, you could pass in those parameters as well. And that's how we pull off the ability to run SQL Server without everything having been pre-installed or you having to run an installation inside the container itself. Okay. Let me go back here. Let's see if there's anything else I wanted to show you. No, that's it. So you kind of see here, and let's just make sure you know where we are in this process of running these demos. Here are 2 SQL Server containers running. Let's be clear on this, right? One of them is called SQL 2. One of them is called SQL 2017 CU10. Those are the convenient tag names for me to manipulate these containers. One is listening on port 1402 and one on 1401. So if I start interacting with these, I'm going to connect to either 1402 or 1401. But remember, one of the other key things here is one is on SQL volume, which is one directory structure, and one's on SQL volume 2. 2 different sets of databases available now for you to write to and change. Okay. Whoa. Not that happened before. All right. Let's go back to the deck a little bit and talk about some other possibilities for you with containers. Okay. So would you ever want to customize one of the things? Well, I'm not suggesting you're going to customize SQL Server. Remember what a container, what an image is. It's a set of files, a layered set of files, and then a program you're going to run in those set of files. And the base one that we have just has SQL Server, and you run it. And then if you want to, you can start interacting with it. You can change it by copying it a backup or making changes. What if you wanted to actually do something like this? What if you wanted to actually take your backup and put it in the image and then build a separate image based on that? Perfect example. You're in a company and you have a set of developers, and you're in charge of the SQL Server dev server. Has anybody ever been in that situation and tried to control that madness? Good luck. So consider this possibility. You want your developers to have a certain version of SQL Server with a certain backup of a set of data that you want them to build off and play and test and dev off on, right? So you do something like this. You make your from base image SQL Server. And remember the layers we talked about? SQL's based on Ubuntu or RHEL. So there's the layering. SQL is a layer, Ubuntu or RHEL is a layer above it. So your image is going to be based on this image. You're going to take a file called yourbackup.back on your host machine. You're going to copy it into that directory structure, okay? And then you're going to run this command. So when you build your image, Docker is smart enough to know how to copy it in like this, build your image. You can then go run your container, whatever you call it, and then you could restore the backup after the fact. So that is one way that you could provide a consistent image by customizing a SQL container, and you would build your own Docker file that looks like this. Here's another possible scenario for you. Let's say that that's not enough. What you'd like to do is you'd actually like to run a script of something more complex scenario. Let's run a script when the container starts up, and the script is responsible for starting SQL Server because there's a bunch of other stuff I want to do. So this copy dot process right here says, take anything in my current directory, which could be a set of scripts, okay, including the ones listed on the screen here, copy those into the image, and this run command, when the image is built, it will run that command not at the runtime of starting the container, but when the image is built, which is changing that script to be executable. And then notice the command. The command is to run a script, not SQL Server. Well, here's what's possible. Number one, that script could look like this. That script says run that db init script, and notice that ampersand sign in SQL Server. And the way this is executed is from left to right. So on the left-hand side, the script is run first, and then SQL Server runs second. And it has to be in that order, because if the last program to run terminates, the container terminates, right? Well, if the script is run first, what does it do? Well, the script can do something very clever. It could go to sleep. It could wait for a period of time and wait for SQL to start up, and then go run a SQL script with SQL command. And then that script could be this. The script could be to create a database and a set of schema that you want to use. This would be a way for you to run a set of scripts now to create a database when the container starts up. Pretty cool. So when that container runs, it's going to take a script and run it as part of starting SQL Server and create a database on the fly. And what we're trying to do, and our objective is to make this a lot more smoother so that you don't do this sleep business. So that you would be able to provide maybe a set of scripts for us and a way that when you run your container in the Docker run command, we would provide a way for you to just tell us where your scripts are, and then we would run those for you. That's kind of where we're headed with this. But this is the way you would do this today if you wanted to customize a container and run a set of scripts. Okay, I mentioned this concept of updating a container. Consider this possibility. If you just want to interact with your data, you're just going to run T-SQL commands and modify your data. You use volumes, of course, or your changes are going to be lost to your databases. What about configuration changes? Well, you could modify the container directly using SQL configuration concepts. You could run MS SQL conf, to do certain SQL parameters, you could run sp-configure, alter server configuration. Consider this other possibility, though. Why don't you use 2 volumes? 1 volume for your user database and 1 volume for the system databases. And then what you do is your system databases have these changes like sp-configure baked into them. And then you make those changes somewhere else, and then you hand it off, you build an image based on that, and now your developers are not just using a database that you agree on, they're using a set of SQL Server configuration changes you want them to build on. That's pretty powerful. And so that's another possibility for you. And now it gets a little crazy, and we're going to show a demo of this. What if I want to update the build of SQL Server? You could shut down your container, start a new container with a new build of SQL pointing to that same volume, and SQL Server will automatically update to that version. You would no longer be patching SQL Server. And then, if it's on the same major release like SQL 17, it's compatible to roll back. Let's see what that looks like. In fact, here's a visualization of this. You're running CU8. It points to this database. You stop it. You start at the SQL 17 latest CU. It starts running, and boom, you're on the latest cumulative update. And then, if you want, you could go backwards. And then if you wanted to go SQL 19, I know this is going to sound crazy to you, but you could do something like this. You could stop the container, you could point 19 to that, and we'll just upgrade it. I'm waiting for like people falling off their seats or something like that. I mean, can we even do that? Can I do that? I'm going to show you in a second how I can do that. But real quickly before I show you that, let me just mention about multi-instance and containers. You do have capabilities in Docker to affinitize Docker containers or control CPU utilization for those containers or set memory restrictions for containers. Or you can use SQL Server concepts for affinity, resource governor, memory limits, max server memory. You have either choice, right? I will tell you in complete transparency, I'm still playing with the Docker concept to see if that's the right path for you to make these changes in multi-instance scenarios with containers, right? Or whether you should use the SQL Server concepts that you use today for named instances to control these. So before let's see, I thought I had let's see here. Okay, yeah, I still have a couple more slides before I'm going to show you my last demo. So quick concept that I just thought of this. Containers are portable. These images are portable. So what about SQL Server on a stick? Could you do something like that? You could build a SQL Server image. You could pull an image or build your own customized image. Docker has a concept called save. You could save the image to a tar file. You could save the tar file to a USB stick. You could then copy that to your laptop or wherever else you want to, or hand it to a friend. You can then load that tar file on that system, and then you can run the container. I'm not kidding. You can now take SQL Server out of a flash drive and start carrying it around. I'm assuming you have licenses for it. I hope my marketing team's not watching this deck. But, I mean, seriously, that's what I'm talking about. I'm really thinking now at conferences to start putting SQL Server on my stick in case I have a problem with my demos and just pop it in and just start running containers. I hope Vin is proud from seeing this slide. One last thing before I show a demo real quick here is the SQL Server Mac Challenge. I was at an event in February called SQL Bits. You might have heard of it before in London. I was presenting on SQL Server on Linux. And a friend of mine, somebody in the audience that I knew, an acquaintance, said, Bob, I love you. I love how you talk about SQL Server. You're a pretty cool guy, but you're a Windows guy, and I'm a Mac guy. And I feel no love from you here. Because when I want to use SQL Server, I have to use Windows emulation and all sorts of things like that. And I don't want to do that anymore. I'm like, I have a challenge for you. In less than 5 minutes, I'm challenging you that you can install SQL Server on your Mac and a tool that's natively compiled for Mac with no virtualization and no Windows. And he didn't believe me. And quite frankly, I didn't even know if I was right. I took a stab at it, right? Because I thought I was right. And I did it myself, and I did a blog post. I pulled down the Docker image on Mac, on my MacBook. I own a MacBook. Yes, you can tweet about that. Bob Ward owns a MacBook. I pulled down Docker on my Mac. I did a Docker pull of the SQL image that I just told you about, right? Because they're compatible. Anywhere Docker runs, we run. And then I installed SQL Operations Studio, now Azure Data Studio, which is a native app. And he went on Twitter and said he did it in 4 minutes. With a reasonable internet connection, I did mine in 3.5 minutes. So if you're a Mac user out there and you don't think we have love and you just want to play with SQL Server and develop on it, you don't need Windows and you don't need virtualization to do it. Okay, let's see some demos. Doing good on time. Okay, let's remember where we were with these demos here. So sudo docker ps. Okay, SQL 2 is one that's kind of independent at this point. SQL 2017 CU10 is pointing to my wide world importers database, right? So I'm going to do something really crazy. I'm going to shut down that container, and I'm going to start a new one with the same map porting of 1401, that same port as the previous container, putting that same volume. But notice here, I am using the latest cumulative update. Do I dare even do this? Please. Here we go. I just updated SQL Server. That is an update of CU11. I just went from CU10 to CU11, boom, done. I'm not kidding. I really want to challenge you. This is a new way of thinking. Instead of patching SQL Server now, I could have actually taken CU11 separately in an environment and tested it and make sure my app works with it, and when I'm ready to go, I just stop one container and I start the next. Now, when I try to query from this, you are going to see an error comes up because right now in the CU cycle, we have script upgrades. We have some scripts that have to run. So if I run a Docker query here, and remember, I'm on the same port. Notice it says SQL Server in upgrade mode. That's because there are some scripts that are running between those CU cycles. So it's not as fast as I just said in the current cycle. When this finishes, though, the same query is going to run. And then here's the beautiful part. I could roll back. I can stop the latest SQL container, and I can start the CU10 one again against that same volume, and you've just rolled back. I'm telling you, man, that to me, if you're out there and you're just living in the world of patching and rolling back and worried about these kind of things, that is crazy amazing. That is really cool. And I want to challenge you that Docker is providing now that way for you to do those kind of things. Has it finished yet? Oh, there we go. There's my query. So I'm really up now. My app's running. I'm running CU10. So now I'm going to get really dangerous. Okay. Notice here, same command. Here's the diff. SQL 19, CTB 2.0. Notice also the word rel. Now I'm really going to blow your mind. I'm going to upgrade to SQL 19 with the rel image when I was using the Ubuntu image. And you're like, can you do that? And I think I can. Let's try it. Port already in use. I got to shut. So I guess I didn't shut down my Docker. So sudo docker stop SQL 1017 CU10. Okay. Oh. Sudo docker ps. Am I still using that port? Oh, yeah, I've got another one running here. Sorry. Sudo docker stop SQL 2017 latest. A few script bugs that I'll fix this in the repo, but before I put it in the repo up there. All right, here we go. Oh, I know what the problem is. I have that container still out there. Docker ps-a SQL 2019. Docker rm. Here we go. I just started the upgrade process for SQL 19. I'm not making this up. So what does it look like? Oh, should we run the query command and see what happens? Do it. It's being upgraded. Let's see what it looks like. Docker, I remember I can interact with the container, right? IT SQL 2019 bash var opt ms SQL log cat error log. You see it's running the upgrade scripts? SQL Server has this amazing property that you think that because you have to go run like the upgrade process in Windows, right, to upgrade, really what happens is SQL Server Engine's smart enough to look at the databases from SQL 17 and say, this isn't SQL 19, I can't use this stuff, so I internally have the necessary intelligence to upgrade it automatically without running a special upgrade process. This is just the engine making these decisions, right? It's going through, it's running it. Uh-oh, is this possible? Bingo. Okay, you got to applaud. Come on, you got to clap for that one. I worked really hard on that. Hey, I'm not suggesting for you to go back right now and upgrade production servers with CTP 2.0 with this. I'm trying to push you for a new thinking for SQL Server and patching and upgrading the software. The one part that's missing here is the rollback part, right? I'm working on it. Maybe I'll come back next year with the next event. Maybe we have something called PASS coming up, right? Maybe I can do the rollback part by then. So that is what is really possible with this technology in a way that you haven't thought of before. Okay. Okay, what about Kubernetes? Very, very popular topic. People are just outside thinking like, I don't even know what this thing is. I had a lot of people come to the booth going, what is that? First of all, I love looking at names. I don't know if you do, guys, but I love looking at names and finding out the history behind them. And Linux, I just love their history. So by the way, Docker was created as a project some time ago, and I still can't figure out exactly why they picked Docker. It was kind of like docking things, I guess. But does anybody know where the whale icon comes from? Is it like some sort of crazy historical thing? It was just a contest they ran. I looked it up. I was like, how'd they pick the whale thing? What's the representation there? They just ran a contest several years ago, and this whale icon won it. But Kubernetes does have a background. That's the Greek word for pilot or helmsman. And Kubernetes is the choice they made because it's all about piloting or orchestrating things. Well, what is it really? Just in a nutshell, think of this scenario. You have this concept called a cluster. A cluster could be a single host with VMs, or it could be a machine, or a set of machines, excuse me. So it could be a set of machines, bare metal machines, or it could be a single machine with virtual machines. And in that cluster is a concept called a node. A node, in the case of a single machine, is like a VM, or in the case of multiple machines, it's a separate machine. And inside a node is a logical concept called a pod. It's a logical concept. And a pod can contain a container, or as you see here, another pod on the same node can contain multiple containers. For SQL Server, as a base way of just running it, you can see in our documentation, we typically have one container per pod. But we'll see in a diagram in a second that we can actually have multiple containers to support availability groups. The other thing you see at the bottom down there is something called persistent volume storage, or persistent claims. For SQL Server stateful containers like SQL, you want to store your database somewhere, not lose it, right? So Kubernetes provides this concept of setting up a persistent storage so you can point data like SQL databases to that storage. And second of all, a really cool thing that Kubernetes now supports, which we're taking advantage of, is called an operator. An operator is all about deployment. So you can take an operator and you can set up a configuration for what an operator looks like. There's a protocol for that. And you can deploy this operator as a container, and then it can do something like this. So if you're worried about setting up a bunch of this stuff, like availability groups, you can use a concept called an operator to do deployment at mass and special configurations of everything you need to run a Kubernetes cluster. By the way, another thing, you'll just find funny stories. I love my team. I love my colleague Travis Wright. I started looking at Kubernetes on our team a while back, and he kept putting the word K8S on there on these emails. I'm like, what the heck is K8S? So I looked it up. Man, people are just lazy, right? But who wants to say Kubernetes all the time? So Kubernetes is the word K, 8 letters, and the word S. That's why it's called K8S. I'm not making that up. That's the truth. That's why we always use K8S. And I told Travis, he's like, of course, Bob, you didn't know that? I'm like, no, I didn't know that. Because I like looking up stuff like that. Okay, what do we have in terms of SQL Server? And by the way, you can try this yourself today with SQL 17, and you can do it in production. And we have an example and tutorial you can run through on Azure Kubernetes Service. So consider this scenario, similar to what I just showed you with a K8S cluster. I've got 3 nodes in this example, and I've got my persistent storage. And I've got a user that's going to connect to something called a load balancer service. Think of that like the listener concept that we have for SQL Server, or a virtual IP. And in fact, I love Kubernetes because I don't have to go build one of these load balancer things. I can just say I want one of those, and you get what's like a static IP, an IP that won't change. So your app can point to that. The load balancer points to the SQL Server container in the pod. Well, Kubernetes is pretty smart. So first of all, and I tried all this, and you can try it yourself. If you crash SQL Server, just crash the thing, Kubernetes is smart enough to restart SQL in that pod. Like, I've tried that before. I know how to crash SQL all the time. So I went and I crashed it, and sure enough, it just restarted in the pod that I needed. So that's pretty cool. It knows how to do that. Second of all, you can go into Kubernetes and you can manually destroy a pod or like kill it. So I killed the pod, and what happened in this example? Well, what it did is it started a new pod, and it doesn't have to be this case, but it on the same node, it started a new pod with a new container pointing to that same persistent storage. That's pretty cool. Well, then what I did is I did something called uncordon a node. I know it's a crazy word, but effectively killing a node. So I went and killed the node, and look what it did. It started a new pod on a new node. Does this look familiar to you? This looks like failover cluster instance. This is exactly the same type of technology with SQL Server we have as failover cluster instance, except there's no failover software here that I had to configure. Kubernetes provides the infrastructure to make this happen. There's one problem with this scenario we've observed. When SQL Server starts up in a new pod, it can take a while, minutes actually. That's not acceptable for a lot of you sitting in the audience. That's not kind of the failover time or the RTO time you're actually looking for. So take a look at this new possibility in SQL 19 preview today, always on availability groups on Kubernetes. Notice here we're using an operator concept to deploy out your replicas. This is going to sound crazy, but now imagine deploying an availability group with an operator concept that we have set up, and the only thing you have to do when this is set up is create a database and add it to the group, and you're done. Whoa. That is way cool, and that's what we're providing here. Well, what else are you providing? Because Kubernetes has built-in capabilities here, notice at the bottom left-hand corner, the primary app points to a load balancer, which points to the primary replica. So if the primary replica has a problem, because we're using availability groups, what happens? Well, the load balancer is pointed to the new primary when the failover occurs. So a failover occurs, let's say it's a sync replica. Again, I'm not using clustering here. Kubernetes just does this for us, right? A primary comes up, the load balancer automatically redirects you to that primary. And then notice at the top, I may have readers going to my secondary replicas. So the reporting apps hit the load balancer pointing to those secondary replicas. They're smart enough to get redirected to the new secondary when it comes online. I have a complete availability group system, highly available, with secondary readers, deployed by an operator with just a few commands. And literally I've seen our guys that do this, like have one script that just does the whole thing. Like here's a script, deploy my AG, start thinking in those terminologies, deploy my AG, and then just start using it. Pretty amazing stuff. And some of the magic of how this works is this AG agent, which is another container running in those pods with those replicas that do all our health detection. So all the great health detection you get from AGs, database health detection, flexible failover policies, they're all baked into this. Take a look at this. We have a tutorial out there right now. You can try it with Azure Container Service. You can set it up and play with it and see, is this something that I could use in my environment going forward? Okay, so 6 minutes left. Time for shameless plugs. So back in December of last year, I thought, and I know I got to be crazy. My wife still says I'm crazy. I'm going to write a book. And you see the upper right-hand corner here, available for pre-order today on Apress, Amazon, and Barnes & Noble, or where else you can find books, is this book I wrote called Pro SQL Server on Linux, including containers and Kubernetes. Here's what the book gives you. And by the way, I believe the release of production will be in November. That's what we're hoping for now. Even though it says like 19 on there, that's going to be a lot sooner. Here's what the book's for. If you're a SQL Server person today and you know Windows, you're going to like this book because it's going to teach you about SQL on Linux. If you're a Linux person today and you don't know SQL Server, it actually is going to teach you SQL Server for concepts that you didn't know that apply to both Windows and SQL Server. I really enjoyed doing it, and here's the other fun part of it. I'm celebrating my 25th anniversary at this company, and inside this book is a history of that 25 years. I've got all sorts of crazy, fun nugget stories of the journey that I spent at Microsoft dating back from OS2 1.1 all the way till to now. And I had the incredible, fortunate luxury of having Slava Oaks, the grandfather of SQL Linux, write the forward for me. And Slava has got some really interesting details of how the project started off. Here are your resources. So when you get this deck, I love putting resources for you. Go look through all these things. At the very bottom down there is the actual pointer to the GitHub repo where these scripts I use today that you can use. And I will go back and make sure that they're bug-free before you get out there and use those. But here's other things. Notice the second point, SQL Linux Labs. For those of you that went through the workshop here at Ignite, a humble apology. But you can go yourself to SQL Linux Labs, that second line, and go do this yourself, including Docker Labs. My colleague Vin Hughes built some really, really great labs for you there. If you go to AKMS SQL Containers, use that shortcut, you can find every documentation resource for how to get started today with SQL 17 containers and SQL 19 containers. Hey, I hope you enjoyed this today. I had fun doing it. I hope you felt it was kind of an inside look at how we do SQL Server containers, how it works under the covers, gives you an appreciation of what's possible for you. We have 4 minutes left in this session, so I'm going to actually end the session now, but I'm going to allow you to come up to the mic for the last 4 minutes, and I will stay here as long as you want to answer your questions afterwards. You've been a great audience. I hope you enjoy the rest of Ignite. Thank you for your time today. Feel free to come.